Yes, today we're going to start a new course that is artificial intelligence. We will discuss about some algorithms and concepts. So we will start with uninformed search. And in uninformed search, also known as blind search, it is a search strategy in which we would solve a problem without using any additional information about the goal. We don't know what the distances between nodes are going to be, we don't know about the cost, we don't know about the directions, we only know about the problem definition. We would know about the initial state, we would know about what actions we can take and what goal we need to reach, and we would explore our nodes and solve our problem based on these information. And we will discuss about some of the algorithms of uniform search. So start with breadth first search. In breadth first search, we expand the nodes level by level. We expand the shallowest node first, meaning we expand the topmost node first. So here we have these levels. So we would only go to this level if we have already expanded all the nodes of this level, and we will go to this level if we have already expanded all the nodes of the top two levels. So let's solve this and see how we implement our queue. So we have our queue, and then we would store our expanded nodes in an array. So let's suppose our starting node is A and our goal node is E. So we need to go to E from A. So we have A, so we would put it in our queue. And then our next step is that we would pick up the value from our queue, which is on the leftmost side, means first in first out. So since we have a queue, so whichever value we have on the left, it was the one who went in the queue the earliest. So we would take A, we would expand it, meaning we would explore it, we would explore all its neighbors, and those are B and C. So we would add B and C in our queue. And since we have already expanded A, we would remove it from the queue and we would add it in the explored array. Now we would look at P, and it is not our goal node, so we would have to apply all those steps again. So we would take B, we would explore it. So from B we can reach D and E. So we would write D and E. And since we have explored B, we would cut it out and write it in our explored array. Now next we have C. Now we would explore C. From C we get F and G. F and G. We have explored C as well, so we write it in the expanded array. Now we would check T. T is not our goal node either, so we would also expand it, and since it does not have any nodes below it, so we don't have anything to write in our queue, so we would just mark it as explored. Now we would reach E, and when we would reach E, our condition would come true that E is our goal state. Since we have found our goal state now, so we do not need to explore the tree any further. So this would be our answer, and that's how we would calculate our breadth per search. So now let's discuss about its time complexity and space complexity. Both of its time and space complexity is B power D. So what is B here? B is the forward branching, average forward branching, and D is the depth of the solution. So both time and space complexity are same, and it is an exponential value, so it is very great. It would be very large. And completeness, so if our graph or tree is finite, then breadth first search is complete and optimal. It would be optimal if the cost for every step is the same, because if we have a solution that is very deep in the tree, and if we have a solution that is more shallow in the tree, so since we're going level by level, we would first reach the solution which is shallow. So yes, it would be optimal, but only if every step has the same cost, otherwise it would not be optimal. So, what are the situations in which it is better to use breadth first search? So we can use it when space is not a problem, because as I said, it is exponential. So the space complexity and time complexity would increase very fast. And when is it better to not use it and implement some other search method? Is when of course space is limited, and all solutions they tend to be located deep in the tree. Then we should also not use breadth first search, and when branching factor is very large. So this was it for breadth first search. In next video we will talk about depth first search. Thank you so much.